VMware vSAN provides a policy-driven approach to storage management, allowing administrators to define performance, availability, and resilience settings on a per-VM basis. Unlike traditional storage solutions that apply the same configuration to all workloads, vSAN enables storage policy-based management (SPBM), giving IT teams the flexibility to optimize performance, redundancy, and space efficiency based on application requirements. By leveraging vSAN policies, organizations can fine-tune storage performance, maximize resource utilization, and ensure high availability for mission-critical workloads. The vSAN policy framework includes key parameters such as failures to tolerate (FTT), RAID levels, stripe width, and deduplication settings. Failures to tolerate (FTT) defines the number of failures a VM can withstand before experiencing data loss. Organizations can choose between RAID 1 mirroring, high availability with more space consumption, or RAID 5/6 erasure coding, space-efficient redundancy with slightly higher write latency. Stripe width controls how many capacity devices are used for storing a single data block, optimizing I/O throughput for workloads with high read-write demands. Object space reservations and deduplication compression settings further enhance storage efficiency, reducing overhead without sacrificing performance. To optimize vSAN performance, administrators should follow best practices such as using all-flash configurations for low-latency applications, ensuring 10 GBE or higher network connectivity, and enabling network I/O control (NIOSC) for traffic prioritization. Additionally, vSAN Adaptive Resync helps balance bandwidth usage during rebuild operations, preventing disruptions to active workloads. Using vSAN Performance Service, IT teams can analyze real-time storage performance metrics, identify bottlenecks, and adjust policies dynamically. Beyond storage policies, vSAN integrates with VMware Aria Operations (vRealize Operations) for predictive analytics, automated workload balancing, and proactive capacity planning. By continuously monitoring workload behavior, organizations can fine-tune storage allocation, prevent resource contention, and optimize cost efficiency in hybrid and multi-cloud environments. By understanding and implementing vSAN policies and performance optimization strategies, organizations can ensure high availability, scalability, and efficiency, meeting the needs of modern applications. Let's continue.